In this lesson, we are going to talk about recursive sequences. So the first thing that I want to talk about is what is a sequence? Okay, it's a list of numbers that we'll see separated by commas where the difference between each number remains constant. So it's going to be the same difference between each number. So either you're going to be adding to, or you're going to be subtracting to, or whatever number that might be, it'll be the same thing between each pair of numbers. Okay? Now, the recursive formula is the formula that we use that basically translates the pattern. Okay, what is that difference between each of the numbers? And these guys over here are all the different ways to look at a term of a sequence. So A1 is the first term, and then any number after that would be AN, where N is the number of the sequence. So if you were looking for the third number in the sequence, N would be a 3. If you were looking for the 100th term in the sequence, N would be 100. So then if you have N minus 1, that's the previous number. So like if you are looking for the 5th term in the sequence, well, what's 5 minus 1? 4. So you would probably use the 4th term, which is the previous number. Or if you're going to use or you're looking for the next number, that would be your N plus 1. Okay, so here's what we're doing. We're going to look for the difference, and we are going to figure out what is that difference and then use that difference in order to make our formula. Okay, so if we look, it says here, write the first 4 numbers of the sequence, and they're giving us the recursive formula. All right, now if you remember, what does this mean? That means the previous term in the sequence, right? So they're giving us the first term. Excellent. So the first term of the sequence is 7. Awesome. We've got to figure out the next one. So if we wanted to find A2, then that is going to be, what's 2 minus 1? That would be 1. So we're going to say A1 plus 3. What was A1? It was 7. And 7 plus 3 is 10. So the next term is 10. So now we've got to find the third term, which means we're looking for A sub 3. And that means I want to plug in A sub 2 plus 3. So that would be 10 plus 3, which would be 13. So what's the fourth term? So A sub 4 is what we're looking for, which means I'm going to use A sub 3 plus 3. And A sub 3 was 13, and 13 plus 3 is 16. So the first 4 terms of this sequence are 7, 10, 13, and 16. And make sure that when you write these down, they're separated by commas. Otherwise, you just have one long string of numbers. Okay, make sure they're separated by commas. Let's look at another one. This time, again, they're asking us to find the first 4 numbers, and they give us the first number. A1 is -3. So -3 is our first term. Awesome. But this time, what is happening between the 2 and the previous term? They're multiplying. Whenever you have 2 numbers right next to each other like that, they are multiplying. Hopefully you remember that from your solving equation days back in Unit 1. Okay, so this is going to say that in order to find, A2, we have to use 2 times A1. So 2 times, what was A1? -3. So A2 is going to equal -6. Awesome. So then we've got to find our third term, which again is 2 times the previous term, which was A2. And we just found that A2 was -6. So what is 2 times -6? It's -12. Go ahead and find the fourth term. So the fourth term would be A sub 4. So we're going to take 2 times the previous term, which was A sub 3. And we just found that A sub 3 is -12. So 2 times -12 is -24. Now, Some of you may be saying, well, but the difference isn't constant. I'm not adding or subtracting 2 each time. No, but think about this. First, we're subtracting 3, then we're subtracting 6, and then we're subtracting 12. Is the constant, or is the difference between those numbers still constant? Yeah, it's doubling. 3, and then the next one I'm doubling it, and I'm taking away 6, and then I'm taking away 12. So that's doubling every time. Okay, so this is still a constant pattern. It's just that we're multiplying, and that will change what that difference is between each of them. But it's still constant. Let's look at number 3. Again, we are looking for the first 4 numbers of the sequence. So this time there's a little bit more involved here. As you can see, we've got our previous term going right there. All right, now the first term of the sequence is 4. Very important. They gave us that first term, so we've got to use it. So then if I want to find A2, I would get 5 times my previous term, which was A1 minus 1. So I'm going to say 5 times 4 minus 1, which is 20 minus 1, which is 19. So 19 is our next term in this sequence. So we do it again. This time we're going to say A sub 3 is going to be 5 times A2 minus 1. So that's going to be 5 times 19 minus 1. 5 times 19 is 95. Minus 1 would be 94. So then the next one, these are getting kind of big, huh? The next one would be A sub 4. So I would say 5 times A3, oops, 5 times A3 minus 1, so that's going to be 5 times 94 minus 1, and 5 times 94 is 470, minus 1 would give me 469. So believe it or not, there is a pattern there, and our rule for that pattern is right here. Okay, so we're just following that. It's kind of like when you were evaluating a function. You're plugging something in, and you have to figure it out. All right, so now let's look at this one. It looks a little different, right? But it's all the same. All it's saying is that for everything greater than 1, any term where n is greater than 1, so basically 2 and beyond, they gave you the first term, okay? So then we are now going to use this formula. It just has this added to the beginning of it, and I don't want that to confuse you. It's just saying basically for everything after the first term. Okay, you might want to write that down, that this means everything after the first term. Sorry, my pen is kind of broken. All right. Okay, so now let's find the first 3 terms in the sequence. They already gave you the first one. It's 2. So then why don't you take that and plug it in and find what is A2 and what is A3. To find A2, we're just going to say that it's 2 times A1 minus 3. Well, what did we find A1 to be? A1 is 2. So 2 times 2 is 4, minus 3 is 1. So that's the next one. Then we're going to plug that in. So now I have A3, which means we take 2 times A2 minus 3. A2 we found to be 1. So 2 times 1 is 2, and 2 minus 3 is negative 1. And that's it. We found our first 3 terms of the sequence. Now it's asking us to write the formula for the sequence. So this can be a little tricky. What we've got to do is we've got to figure out what is the pattern. Okay? There's 2 things we need to figure out. We need to know what is A1, and then we need to figure out what is the difference so we can find what is AN. Okay, so what is happening with that A1 to get the next number? So think about, how do you get from 2 to 6? And does that work from 6 to 10 and from 10 to 14? So I'm thinking that from 2 to 6, we could either multiply by 3 or we could add 4. If I multiply by 3, then 6 times 3 does not make 10. But if I add 4, then 6 plus 4 does make 10. And 10 plus 4 does make 14. So I'm thinking that plus 4 is going to be that common difference. So let's start with A1. What did we find A1 to be? A1 is the very first term, so that is 2. Great. Now to write that recursive formula, we need to take the previous term. How do we write the previous term? We're going to use A with n minus 1. And then what are we doing with that previous term? We're adding 4. So here is your recursive formula for this sequence. In this example, we are asked to again write the recursive formula, okay? So we've got to start by finding our A1 and then write the rule for AN, okay? So first of all, what is A1? So A1 is our first term, so we're looking at 3. So I'm going to write 3. Then we've got to figure out what is the difference between each of these terms. So we could say 3 plus 3 is 6, but is 6 plus 3 12? No, it's 9. So let's try something else. What about 3 times 2? Is that 6? Yep. How about 6 times 2? Yep, that's 12. How about 12 times 2? That's 24. Looks like we found our rule. So we're taking 2 times the number, right, to get the next number. So I'm going to say 2 times, and how do I write the previous number? A with sub n minus 1. So you could leave it in the parentheses like this, or you could say an equals just 2a sub n minus 1. That's it. That's how you write the recursive formulas. Why don't you try some practice?